what do we do with odd numbers? I don't expect you to remember pretty much anything from this other than when you have an odd number fatty acid, we don't just throw it away. Okay? What we do is we do a number of things. So if we end up with an odd number, or if we start with an odd number fatty acid, then at that last cleavage, we're going to end up with a 3-carbon instead of a 2-carbon acetyl-CoA. We're going to end up with propional-CoA instead of acetyl-CoA. What do we do with this oddball, 3-carbon? We can't put it to the citric acid cycle. Acetyl-CoA is the entry molecule, not 3 carbons. So what do we do with it? Well, we can rearrange it to make succinyl-CoA. We can do a number of reactions, and that will rearrange it, and then we can feed in to succinyl-CoA. Just remember, we're not going to waste anything, right? If it's a carbon, we're not going to waste it. So it can just feed into the citric acid cycle. How about unsaturated fatty acids? They're all, and this, I have trouble with this, and I have yet to reconcile myself with this process. Unsaturated fatty acids, natural ones are going to have what conformation, a cis or a trans? Cis, right? Man-made is trans. So all unsaturated fatty acids are cis. But what does the body do? It isomerizes it to a trans. And then it goes on. So why are trans fats bad for you? See, I don't know. I have to figure that out. I've yet to learn that. So if someone finds out in their future, please email me. Because I don't know what, I guess maybe the body doesn't know what to do with being presented that. I don't know.
If it's now a trans fat, is it?
Let's look. So I don't really know. So this is what's going to happen. So here, this is really tiny. I don't know what to do to make it better for you guys. Do you see any of this back there? All right. I'm not going to ask you to remember too much from this, but here we have a fatty acid with a couple double bonds in it. So here we have 6 carbons, so 7, 8. So we don't get a double bond until 9 and then 12. So we're going through our beta oxidation. We do it 3 times and then we're stuck. Oh, what do we do here? So we want to put a double bond here, right? But that's not going to happen. So what we do is we take this and we make it a trans, and then we do beta oxidation. So it isomerizes it from here to over here, and it makes it a trans. So enol-CoA isomerase will make a cis double bond between the beta and I guess the gamma carbon, a trans between alpha and beta.
So when it isomerizes,
it moves it over.
It completely moves.
It moves it. It moves the position and then makes it a trans. Yeah. This is a pretty powerful isomerase, right? And then it goes through, so it's happy. We've actually gained some, work. We didn't have to use the FADH or FAD to do this. So you're not getting that money out. You're losing money by having an unsaturated fat. Because remember that oxidation to put that double bond in, you got an FADH2 out. That was 1.5 ATPs. We're not getting that money here. Not happening. And so then we go through, we get our acetyl-CoA, we do it, and then we have to do it again. We use another, this is all I want you to know from it, that you have to go from a cis double bond to a trans double bond, and that you're not going to get the FADH2 out of it. Oops. we're not going to get the FADH2 out of it. Ketone bodies are a group of molecules that can be used for energy in most cells, but particularly in heart, muscle, in the adrenal cortex, or during starvation. So they result from an overproduction of acetyl-CoA from beta oxidation. The brain can adapt to using the ketone bodies after starvation. So we're getting a lot of acetyl-CoA from beta oxidation, and what can we do with that acetyl-CoA? So if you have a high intake in lipids and low in carbohydrates, so what diet is that? High lipids, low in carbohydrates. Is it the Atkins?
Yeah.
I think it was high protein.
It's mostly
High protein?
Ketone.
Yeah, high protein.
But don't you end up eating a lot of fat too, though, if you do?
Eating a lot of steak and stuff, you're eating a lot of fat.
Yeah, if you're eating a lot of steak, you're going to be eating a lot of fat. So high intake in lipids and low in carbohydrates, you're going to have ketone bodies result. So these are these three molecules. You need to memorize these three, what they result from. If diabetes is not controlled well, during starvation, you're going to be going to the fat in your body for the energy. So actually, you can actually smell the acetone in people's breath during ketosis. It's going to overwhelm the buffer in your blood and disrupt your sodium and potassium in your blood. And what you're going to happen is you're going to dehydrate and can be fatal. So that's one of the things that you healthcare workers are going to look for in uncontrolled diabetes is the it results from the overproduction of acetyl-CoA.
We did a thing in our neuroscience class once where we did a bunch of different ketone bodies and like different scents and stuff, and like half the class could smell certain ones and the other half the class couldn't smell other ones.
Okay, so that supports.
Yeah.
Does everybody who has diabetes have the smell or just
If their
uncontrolled?
sugar's above.
Yeah, this is from uncontrolled diabetes.
You could smell it.
You can smell it. If you can smell it, you can smell. You can
And
really
we're seeing a
smell
lot
it.
of patients with diabetes, and if they come in before the study and they weren't ready, you can smell it on their breath.
Wow. So let's take a look at how does an overproduction of acetyl-CoA result in these three molecules, guys. You don't need to know the structure, but these three molecules are our ketone bodies. So here what we're doing is we're condensing two acetyl-CoAs. We're condensing two acetyl-CoAs to get acetyl-CoA. You don't need to know that. But what we can do is we can then cleave this coenzyme A off, and you get acetoacetate. That is one of our ketone bodies. You can reduce this carbonyl to an alcohol to get beta-hydroxybutyrate. And then if acetoacetate is decarboxylated right here, then you get acetone. So I'm just showing you how they are related to each other. What I want you to know is what do they result from? Overproduction of acetyl-CoA, and what their names are. So you can see acetoacetate and beta-hydroxybutyrate are related by this reduction, and acetoacetate is related to acetone by the decarboxylation. And for fun, I just put the structures up there, the ball and stick. I thought it was pretty. All right, we already covered this, but we're going to just mention it again. Atherosclerosis, again, the lipids are transported by lipoproteins. Remember, the lipoproteins are a ball of phospholipids. When inside you have your triglycerides, you have your cholesterol, and then you have an apoprotein. And whether you're LDL or HDL depends on how much protein you have. Remember, protein, I'm starting to lift again. All right, so, and I thought it was wise to run 3 miles last night and 3 miles this morning again. Not very wise, because I'm sore standing up here. So that was not very wise. But I'm hoping that I actually gain weight because I will have more muscle. So remember that. High density lipoprotein is going to have more of the protein. That's why it's good. It has less of the lipids. And then low density lipoproteins are going to have more fats. This is our apoprotein. I don't know why it has little mountains on it, but this is our apoprotein. Remember, an apoprotein is a protein without the prosthetic group, so I guess this whole thing. You have your phospholipids, and you have cholesterol and other fats inside there. So this is just our carrier. Remember, cholesterol is not water soluble, so how are you going to get that around your blood? You're going to find some way. So what you do is you cover it in a ball of phospholipids. And again, this is the same slide that we showed before. Our endocytosis, this is how we're going to get cholesterol into our cell. If we have overproduction, we're going to then get that receptor inhibited.